Hello.
Hello. Hi.
Welcome back to another video with the Yeti family. We talked about how to make this guy move last time using buttons. And you might recall that we have this issue where you can press the button and you just click it and it doesn't always go. You have to hold it down or just kind of get lucky. Because what happens is this bit at the bottom, there's this wait for half a second. And we only read what the button is doing up here, and that's gone real quick. So you have to be holding the button when this is happening, right here. And then it sleeps for half a second and doesn't do anything. So unless you're pressing the button during this time, it won't move. And it's much more likely that you're pressing it during that half second. So you have to hold it for that whole half second until this part's done and it comes back around to the top of the loop and hits that again. So that's why that happens. Now, something I've never tried. Yeah, if you hold both down, it doesn't move. Move to the right one because my right finger came off after. Yeah, you're thinking about that?
Mm-hmm.
So, I have a fix, and Sister Yeti actually asked how we'd fix that last time, and so that's what we're going to do this time, is figure out a way to make it always go, and you don't have to hold it down. So I could have asked you ahead of time so you'd think a little bit, but I'm going to put you on the spot. What do you think, just any random idea that you can think of to kind of fix the issue where we have to read the button using this thing all the time, but then and then it will move every time you click it?
Well, I don't know about the rest, but you can, not do delay 500.
Okay, let's give that a shot. See what happens. It's always worth trying things out to see what happens when you try it. So if we get rid of the delay, you don't have to hold it for half a second before it goes, right? What do you think is going to happen when we press a button? You want to press the right button? Come
Which
over.
one?
The right button there.
This one?
Uh-huh. Whoa!
Oh, he goes the other side.
Go to the left. Okay, try to click as fast as you can. Just... Okay, let me try. Nope. I can't click fast enough.
Okay, so maybe you can put
What do you think's happening? Before you hold that thought for the next idea, I want to hear it. But before we move to the next idea, why do you think that happened?
I think because it doesn't have any time to see how much time you're supposed to hold it. So it's like saying, so when you press it, it just goes to the other side because it doesn't know how much you're supposed to hold it to make it move.
Okay, it's good idea, good thought. You have something, sister?
Well, there's no delay, so that affects something. I don't know what, but it affects something.
Okay, let's try making a shorter delay, but still have a delay. See what the difference is. Okay, so now it doesn't fly across the screen, but notice that sometimes it goes more than one.
Yeah, because since you might be holding it a little longer than that delay.
Mm-hmm.
So then it skips it. Like if you go really fast, it'll go one, but then if we hold it, it's gonna skip those.
Yeah, and it does that because when it gets down to the bottom for this delay, that's how long it waits before it comes up to the top again. And so with no delay at all, it doesn't wait at all before it comes up and reads the button again.
Oh.
And this thing is counting thousands, maybe a million, I can't remember how fast this particular thing is, but it's very common for these to go millions of times per second. So if I hold this for more than 1/1,000,000th of a second, it's going to move more than one. Doesn't matter how fast I click this, I am not clicking it faster than 1/1,000,000th of a second. I just can't do that. Maybe it's like 1,000th of a second. And 1,000,000 divided by 1,000 is 1,000. So say I took 1,000th of a second to click that. It's going to read it 1,000 times and move it 1,000 times to the left. In just tiny little click. So if you don't have a delay, that's what happens. It just rides through this again and again and again and again and again as fast as it can. And so even the shortest time that you as a human can hold it is thousands of times for that to go. And so to us, it just looks like it jumped completely.
Can we try a different delay?
So if we try this 100 delay, that's what we did here. It's the same thing, but it just takes a little longer. But we still have... So this looks like it could have fixed it, because we can barely click fast. I don't think I have yet to click this faster than the 100 millisecond delay. Like me, oh, maybe that time. Okay. So it's a lot better than a half second. I can click this, and I can manage to click this. I can barely manage to click it fast enough for it to be skipped. But now look at that.
Yeah.
He moves really fast. We don't want him to move that fast. Right?
He's gonna read your rights.
So we don't want him to move that fast, but it did help that the button problem is a little bit better. So it's still not really fixed, and we introduced a new problem. So what we really want to do is we want the time to be back to 500. I just undid all those changes, but we can't use the delay. So I'm going to introduce an idea called ticks.
Ticks?
When you hear tick, what do you think?
I think of a black thing sucking blood from you.
I figured you'd say that.
I think of clocks.
Think of clocks?
Tick-tock.
Yes, that's the tick we're thinking of. I was trying to find the clock that was sitting over here, but it's not. It's not here. There we go. Okay.
Tick-tock.
Right. This isn't a normal clock. This is a timer. But you know, as this goes down, a normal analog clock will tick, tick, tick. So that tick is what we're talking about. In a program like this, we want to loop around and do the same thing over and over again, but we want to do things only every time the clock ticks. So we want to introduce the idea of only moving when the clock ticks. How's that different than this? Well, let me show you. First off, let's take this delay, and we're going to introduce a constant up here. We're going to call it wow. We're going to call it const int tick time. Okay. It's const because we don't want to change we want all of our ticks to be the same amount of time. And this is an int. It's a number. We're going to call it int tick time.
Tick tock like a clock.
Now, we need to know when the next time the tick is supposed to happen. So we're going to, I'll explain why in a second, but this is an unsigned long next tick time. So this is the next time the tick is supposed to happen. We're going to start that at 0. When we get to the bottom, we don't want to delay. We want to check if we're at the time we want to run the next tick. Right? So to get the current time, we need this unsigned long. What unsigned long means is it's a bigger number. Int is a number, long is a bigger number. Unsigned just means that it can't go negative. So we're going to have a positive number that's really big. Starting at 0 is what we set up here for next tick time. The current time is we get from this function called millis. Millis as in millisecond. Okay. Yeah, his arms are flapping really fast. Brother here is just staring at that flappy, flappy, flap. That's the other thing that happens.
Slower.
We never restarted it at the 500 milliseconds. It's still doing 100 milliseconds. So he's flapping his arms 10 times a second right now.
Oh.
Okay. So over here in our new code, we're going to get the current time, and then we know the current time now, so that's the start. So every time we go around this loop, we're going to get the time. And then we need to check if that time is past our what we expect for the next tick. Let me just show you here. So if the time is greater than or equal to next tick time, now we can actually perform the logic. So what's going to happen is we only get inside this if time equals greater is greater than or equal to next tick time. We only get inside of this little chunk here if it has been long enough. But how do we know if it's been long enough? Well, we have to set next tick time to, we're going to set next tick time to the current time plus what our tick time is supposed to be. So what that means is the first time we get time, it's going to be greater than or equal to 0 because we're always going to be greater than or equal to 0. So the first time we get through here, we're going to run this tick. And then we're going to set next tick time to be whatever time is right now plus 500. And so we only get into this block again if it's been more than 500 milliseconds. So that's similar to the 500 delay in that we only do this every 500 milliseconds. But what we can do here is I can take this chunk of code, I'll put this up here. And now all of the stuff that was in our loop is inside of this. So we only print to the LCD, and we only move the position, and we only set the cursor, and we only flap his arms, and we only do all of that if it's been the 500 milliseconds, because we're now inside the next tick. But we still read the button every single time the loop goes through. So there's no delay to wait for reading the button, because that's outside of the tick. We read the button as much as possible, as fast as possible, but then we only do anything with it every 500 milliseconds. I'll tell you now, this is not complete. This will still be broken in some way. But let's try it out. And while this is building here and loading, how do you think this might be broken? What do you think might be wrong with it?
What might be wrong with it?
If you don't see it, that's okay.
Nope. I'm kind of eyeing.
Does this seem any different than it was before?
No. Press it for 500.
I still have to hold it down.
That's broken. That's what I was going to say.
So it's the same as it was before. Well, why is it the same as it was before?
Because it only loops through it if it's 500 ticks.
Yeah. And this time that we read the button, we read it every single time, but then we only use what we read when we go into the tick.
I was going to say that too.
Okay, so explain it. Why is that a problem?
Well, it's a problem because you may press the button, but you only use it after the tick. So then you're just pressing the button because you're pressing it. And then it doesn't do anything.
And then it doesn't do anything. Very good. Okay, so we need to remember if we pressed the button since the last tick happened. So what we need to do is we need to take this button pressed and save it out. Oops. We need to save it outside of the loop. Okay, so we need to remember that. We're going to set this to false by default. Okay, so if it was pressed before the loop happened, if it was pressed before the tick happened, we'll still remember that because we're not going to set it back to. We're going to have to reset it every time. But what the difference here is because I put the bool part up here, we are declaring pressed 1 and pressed 2 globally. Is what this means. The program will remember pressed 1 and pressed 2 all the time. And then we set a new value at the start of the loop, but what it was before is still remembered. But this is actually the exact same thing. We changed nothing right now. What happened, I moved this to be global, but it's still going to be reset every time we start the loop. What we actually need to do is we need to have, I'm not coming up with a good name, so I'm just going to put now. Or loop. Right. We need to know what it is every time we read it, but only set what was remembered if it changed. And actually, the only thing we care about right now is whether it was pressed. Like if we press it and then we release it, we don't care that it was released. We just need to know that it got pressed. It will take a lot more complicated logic to know like if it's pressed and released within the loop, or there's a whole lot more you can do with it. But all we care about right now is that it got pressed at some point before the next tick happened. So what we need to do is we're going to set pressed 1 and pressed 2 to this new value. Okay, but this is still the exact same thing again. Like whatever loop was, if it's true or false, we're now setting the thing from outside the loop to the new value. We only want to set it to true if loop was true. So there's two ways we can do that. We can do this with an OR. These two bars means OR. I'm saying if pressed 1 was true before, great, keep it true. Or if pressed 1 loop is true, set it to true. So what that's going to do is, if loop is false because I released the button, but I pressed it in the past, this one was true. So even though loop is now false, that one was true. And so it's going to stay true. Another way we can do this is, if. This one I think is a little clearer what's happening. So if this new thing was true, then we set the old one. Okay? And what I can do actually is just read it inside the if. I don't need to save it. And then we don't have to worry about having a weird name in there. So if the button 1 was pressed at some time during this loop, we record that it was pressed. And same thing for button 2. But then, if it ever goes false, we don't set it to false. And so it will stay true by the time we get to the next tick. And now, if we try it, Catherine, do you want to press one of the buttons now?
Mm-hmm.
Okay, just press once. Okay, now press left. Okay, what do you think happened?
That's weird. Why didn't it go left at all?
Well, that is the second part of the question that will make sense once we understand the first problem. I hinted at it a few times when I explained what we're doing here.
Button 1 is true, so it doesn't change button 2 to false. Now,
you're on the right track. We only ever set them to true, and we never set them back to false. So they're just going to stay true. You can click it once, and it will always be true forever. What we need to do is, once we have used them, and we're like, okay, we have used these buttons, and we have handled them. That's how we say it. We say we handled them. We handled that button press. Now we set it back to false, to say that the next time we come through on the new tick, it's back to the reset value of nothing. And we can pick up on the new button press. So you need to remember between loops, only set it if something changed, and then reset after you use it. That's all. Those are all the things that you need to do. So now I click,
It moved more than one.
it did. It moved more than one. I think what had happened there was, I think I was holding it over a loop. Like, I got at the end of one loop and into the start of the next one. So it went one because it was the end of that 500 seconds. And then I was still holding it into the next 500. And so it counted it twice. I think that's what happened.
But it was at least you could see it move, not like when we did delay 100. It just skipped.
So now if I hold it, it works because I'm holding it across the 500s. If I just click it once, it doesn't matter how fast I click it, it will only go every 500 milliseconds. And if I just click it really fast, it only moves once. So that, you saw there's still some edge cases where it can go twice. But that is how you fix the button holding. You don't have to hold the button anymore, and it doesn't zoom around because you got rid of the delay. So what we can do is we have this thing with ticks. We remember how long it's been since the last tick, and we say how long we need to take to the next one. We read the buttons every time, but only save the changes, not the value, because then nothing changed. And then we reset the buttons after we use them. So, make sense?
Yeah.
Any last questions before we end this one?
So, two things. So you said we were gonna make like a mini game there's like rocks.
That's coming up.
But will it go like side to side or like up and down?
It will be side to side because the screen isn't very tall, right? Meteors coming down from just two lines wouldn't really work. So, brother here just announced the next part of the project, and that is we're going to have rocks starting to come across the screen. And you're going to have to avoid them. All right? So, hope you're looking forward to that, and that should be coming out soon, and we'll see you next time.
Bye. The man also says bye.
He is waving, that's true.